Okay, we're going to jump into 6.3 here. This is just going to be a quick follow-up video. You already have access to another video that'll go a little bit more in depth, but this might show you a different strategy to the binomial theorem and expanding these binomials. So first, I wanted to kind of highlight what we're doing here, right? So you've seen this before. If you have something that looks like this, x plus 4 squared, right, you would rewrite that as x plus 4 times x plus 4, and then you might remember from previous classes that to evaluate this or to expand this, you would use a FOIL method, right? You could also use a box method, and it wouldn't be that bad. The problem is that when you get to something that looks like this, x plus 4 now to the 7th power, right? Well, now you have to write this x plus 4 7 different times, and then you would have to FOIL and FOIL and FOIL and FOIL and FOIL, and it would be a lot of multiplication, right? And so you could do it that way, but it would take you a long time. There's lots of places to get confused and make mistakes when you're expanding something that's 7 times, right? Or even more, right? It could be 15 times, okay? And so what happened is we came up, well, not we, but some mathematicians came up with a different way to do this, and Pascal is the one that created this Pascal's triangle. And basically what it is it's a pattern that allows us to expand these binomials without actually doing multiplication. So it's almost like a shortcut, even though it still seems kind of long. And so this is how it works. You kind of build yourself a pyramid here, right? And notice that it goes from 1, and then we have 2 dashes, and then 3 dashes, right? And so you build a pyramid, and then I've already got it all filled in, but it has ones all the way down the outside, and this is how you fill in the rest of the triangle here, is that you add these two numbers together, and they give you the next number. So 1 plus 1 is 2, okay? And then we'll keep going. 1 plus 2 gives me the next piece, which is 3. Okay, and same thing here, 2 plus 1 is 3. And so that's how I'll fill in the rest of this triangle here. And notice that this triangle stops, and that's just for the sake of time and for the sake of space, but this triangle can be expanded, and it can keep going and going and going, and it never really ends. But for the ones that we're going to work on today, this is probably good. And then the other important part to note is that when we start to talk about the rows, right, we have this top row, okay, and then so on. It starts with row number 0. So this is row 0 all the way at the top, and then row 1, 2, 3, 4, 5, and 6. Okay, and that's going to be important as we move forward here. So it starts at row 0 and goes down. Okay, so let me show you how you use this. So this one says expand the binomial x plus y to the 4th power. So the first thing that we want to note is what is our exponent. In this case, our exponent is 4. So that means that I'm going to use row number 4 for my triangle. So the way that I like to do this, and there's different ways to organize it, is to check out what your row is. In this case, it's row number 4. Okay, and then what I'm going to do is I'm going to write all those numbers from row 4. I'm going to write them below here as I start to expand this thing. So row 4 looks like this. It's got 1, 4, 6, 4, and 1. Okay. And notice that I space these out so that I have some space in between, because I'm going to have to fill in some different pieces here. All right. Now the next step here is to identify the first term of this binomial. In this case, it's an x. Okay, and so what I'm going to do is I'm going to place an x next to each one of these numbers. And here's the deal with these x's. If I were to multiply this out, obviously there would be some exponents involved here, right? Because like x times x is x squared, and so on and so on. And the pattern, the way that this works is we're going to start with the highest exponent over here as 4, because remember, that's what I had at the original problem. So I'm going to start with a 4 there, and then I just count down 3, 2, 1, 0. And then we're almost done, but notice there's a second part here, and that's the y, right? We have a y also in here, so I'm going to place a y next to each one of these terms. And then the thing that we have to remember is for the y, we're actually going to count up to 4. So 0, 1, 2, 3, 4 for the exponents. So just to recap the steps, everybody. First, we identified the exponent, which was 4. So I'm using row number 4. I placed all of those numbers from row 4 with some space in between. I then wrote the first term, which is x, and I counted down with the exponents there. Then I wrote the second term, which is y, and I counted up with the exponents. And so now we've got all the pieces. I just have to simplify if I can, and I can a little bit here. You might remember that if y to the 0 power is actually just 1, because anything to the 0 power is 1. So that part essentially just goes away because it's like we're multiplying by 1. And so I'm going to simplify this. 1 times x to the 4th is just x to the 4th. Then we have plus, because this is a positive 4, plus 4 x to the 3rd y plus 6 x squared y squared plus 4x y to the 3rd plus, again, x to the 0 is going to go away because it's just multiplying by 1. So we have 1 times y to the 4th, which is just y to the 4th. And so we get this super long polynomial here, right? And this is what we would get if we were to multiply that whole thing out. Okay, if you didn't totally grasp the pattern there, that's okay. We're going to try it again on the next page here. So notice, I'm going to actually skip letter B. I'm going to go to letter C because this one has a number in it. So first we're going to notice from letter C what our exponent is. In this case, our exponent is 3. So I need to go back to my triangle, and I need to go to row number 3. Okay, so row number 3 is right here, and my numbers are 1, 3, 3, 1. So I'm going to go ahead and write those out. 1, 3, 3, 1. Okay, and then I'm going to start with the first term here. Let me just space this. Okay, so I'm going to start with the first term, which again is an x. So each one of these needs an x. And hopefully you remember that we're going to need some exponents here, and we start with the largest exponent. In this case, it's going to be a 3 because that's what we had in our original problem. So 3, 2, 1, and 0. And now we have the second part here, which is a 5. So I'm going to put times 5, times 5, times 5, and times 5. And we need exponents there starting with 0. So 0, 1, 2, and 3. And now we're going to have to simplify, and this one does need a little bit more simplifying because we have a 5 here instead of a y, which is what we had in the last problem. So check this out here. We'll go ahead and start to simplify this. Anything to the 0 power is just going away because it's like multiplying by 1. So we have 1 times x to the 3rd, which is just x to the 3rd. And now we have to do a little bit work on this next section. So I'm just looking at this piece here. So we're going to do it like this. Let's see, it's going to be 3 times 5 to the 1st power, which is just 5, which is going to give me a total of 15, and then there's an x squared. And now we'll move to the next part. So we've got 3 times 5 squared, which hopefully you remember is 25, and then 3 times 25, which is 75, and that's x to the 1st power. And then all the way to the last section here, well, x to the 0 goes away. We have 1 times 5 to the 3rd, which is 125, okay, which is just a positive 125. And we end up there with that expanded polynomial. All right, last one that I'm going to do here. Similar process, except notice we've got a negative number in there, so that makes it a little bit trickier. But we're going to start the same way. We're first going to identify which row we're using. We're using row 4. Okay, so I can flip back here, check out what row 4 is. and that's going to be 1, 4, 6, 4, and 1. So I'm going to write that out. 1, 4, 6, 4, and 1. And then we look at the first term. In this case, it's an x, so everything needs an x here. And I'll give you a second to think about what exponent we need to start with here as we write our exponents for the x's. And hopefully you're remembering that we start with the largest exponent and count down. 4, 3, 2, 1, 0. And again, I start with whatever is right there, right? That's a little 4, so that's why I started with 4. And now we need to write the second term in this binomial, which is -2. So notice I'm going to put it in parentheses so I don't lose any negative signs. And then hopefully you remember you count up. So 0, 1, 2, 3, and 4. Remember, this is just a pattern, so we're just kind of following these steps right now. So if you get to the homework and you're getting a little bit lost, just go back, watch the video, see what the pattern is, and you can pick it up. And now we got to simplify here. So we said anything to the 0 power is 1, so that's just gone. So this just leaves me 1 times x to the 4th, which is just x to the 4th. And then we'll keep going here. This is going to be 4 times -2 to the 1st, which is -2. And 4 times -2 is -8. And then we've got x to the 3rd. So hopefully you're noticing how I'm kind of going piece by piece here. We'll go to the next part. This is going to be 6 times -2 squared, which is +4. Okay. And then 6 times 4 is +24x squared. And I'll keep going to the next section here. So 4 times, let's see, -2 to the 3rd power, that should give you -8. If you're using your calculator, you have to use parentheses around the -2 or else it won't give you the right answer. And now 4 times -8 is -32, and it's x to the 1st. And then lastly here we have x to the 0, so that's gone. And then we're going to end up with 1 times -2 to the 4th power should give you a +16. So that's just plus 16 all the way in the back there. And we end up with our final polynomial. Okay, so last time here, right, all we did was first identify the row by whatever our exponent is. We laid out those numbers with a little bit of space in between. I then added an x because that's the first term here, right? So whatever the first term, then that needs to be added. And you count down with the exponents, 4, 3, 2, 1, and 0. I then wrote the second term, which happened to be a -2, and I counted up with those exponents. And then I simplified each piece part by part. So I started with 4 times -2 to the 1st power, which is -2. 4 times -2 gave me this -8. And I did that for each one of those terms. All right, thanks for watching.